Good to see everyone. Thanks for attending this talk. My name is Chad Kroll. I'm a local here. And so I took the Mopac, that's the picture that you see on the screen. I learned the reason why they call it Mopac is because it's Mopacked every day. There's increasing a number of Teslas as well. And so the Department of Transportation is working on a project, and it allows the Teslas to report back home. It's called Less Pack. That's my stand-up for today. So I'll be here all day. Shameless plug for if you are local here. We're having KCD, Kubernetes Community Days, on April 12th over at the Palmer Event Center. I encourage you to check that out if you haven't already. And then we have our monthly meetups, the ATX Austin Kubernetes meetup, which is over at the Capital Factory once a month. So either ask me about that if you see me later in the day, or check those out on your CNCF community channels. So my name is Chad Kroll. Again, you can find me at Chad M. Kroll. Don't forget the M on the socials. And I just joined Civo as a senior platform engineer, so very excited about that. Also the author of acing the Certified Kubernetes Administrator exam. So if you haven't checked out that book, it's on the Manning site. And I love helping people pass the CKA exam. It's been a passion of mine for the past 5 years. I've been a trainer at both Linux Academy and ACAL Guru, and we've had a lot of people pass the exam. It's just a good feeling to have people properly prepared for a career using Kubernetes. All right, so into the talk. So this is a talk about kind of a machine learning app or project that we can apply to our web application firewall. And I want to back up for a second and talk about some concerns which would cause you to use a web application firewall. And this applies across the board, whether you're on Kubernetes or not. So we have, data breaches, which everyone knows, getting unauthorized access to a system, DDoS attacks, distributed denial of service. So, overwhelming the app servers with requests and just shutting everything down. We get those a lot at Civo. And injection attacks. So injecting malicious code or commands in your app. So this could lead to data manipulation or unauthorized access. Cross-site scripting, that's also a common one. Involves injecting malicious scripts into a trusted website. Cross-site request forgery, so this tricks the users into performing unintended actions without their knowledge. We also have phishing attacks, which create fake websites to mimic an organization's web app to trick users into going to that one versus the one that we know or that we want to go to. Malware infections, and that's pretty common too. Distributing malware, taking over a system, and ransomware and all that. You have brute force attacks, which attackers will attempt to guess usernames and passwords and find a way to kind of guess their way into finding that valid credential. And then zero-day vulnerabilities, which we'll go into in pretty good depth in this presentation, which are vulnerabilities in software that have or have not been found yet. And as a interesting use case being that we don't know what we don't know, right? So, and then we have insider threats, which are, all of us working at an organization, social engineering and all that. So these are all concerns that we have, which then would allow us to apply certain techniques such as firewalls, web application firewall. Just the difference there being that the web application firewall focuses on layer 7 versus the firewall at layer 3 and 4. So we're actually doing a deep analysis on those packets coming in, and deciding whether that's a valid packet, an authorized packet, to let that HTTP or HTTP request in and gain entry into our web app. So every time you're made aware of a vulnerability, you can add in traditional WAF solutions, that is, you can add a signature to your web application firewall. This signature, there's a couple challenges with applying these signatures to your WAF. So there's the known vulnerability, knowing that it exists, and also there's the signature that you have to apply to the firewall, because there's quite a few manual interventions that are required. So that creates a lot of solutions with administrators like myself trying to apply these signatures and therefore block bad requests. So this is kind of the timeline and what happens during this process. So the vulnerability exists. This is in a optimal use case. So the vulnerability exists. It's then published on something like a CVE site or in a common vulnerability database. A signature is then created for it, and then the signature is then deployed. That's the common timeline, if you will, where a vulnerability is presented, and then also that signature is created and then applied. But there's a problem there, and the problem lies in the time that it takes for this process to play out. So there may be weeks or even months. In the case of the famous Log4j or Log4Shell, companies remained vulnerable for years, and that's due to just unaware that this vulnerability exists, but also there are certain mutations of vulnerabilities, much like we have COVID mutations, and there's certain iterations of this vulnerability over time. Same applies in the case of applications. And there's also more recently the Clarity Team 82 generic WAF bypass. So there is a vulnerability out there that allows you to bypass the WAF entirely. So here's the problem where the vulnerability exists, but it hasn't been applied yet, or that signature hasn't been applied yet. And there's this window of time where you remain vulnerability potentially up to years in some cases. So the problem or the challenge lies in the fact that many WAF solutions are based on static signatures. So these signatures have to exist, and you have to apply these signatures in order for your application to be safe or protected. So essentially, you'll never be protected from zero-day attacks because there's not enough. Before you know it, you're already vulnerable, and zero-day attacks, hence zero-day. There's no time to apply that signature. So this window gets bigger and bigger. It creates a problem for organizations, and hackers could potentially use this exploit to their advantage. Also, when applying these signatures, there's a lot of false negatives and false positives. So false negatives pose a security risk, causing data loss. So when you're not detecting these vulnerabilities, so they leak through, even though that signature is applied. That creates a problem because you have all the problems that we just discussed. We have account takeover. We have all of these issues that you've introduced and a backdoor essentially for malicious actors. And then you have false positives. So these false positives can block intended users of your application as well. So you have actual valid users of your application, your customers that are relying on your application for uptime and high availability. They are denied access to your app and causing essentially downtime, which causes your business money, and also is a huge problem that you don't want, obviously. So there's kind of back and forth, or there's never really kind of a happy medium. You're always kind of tweaking it back and forth to try to find this perfect mode, or perfect place between not allowing and allowing, not allowing the bad and allowing the good. So here's where this ML-based web app security for Kubernetes enters, and this is not just for Kubernetes, but it applies to, so a lot of people think that Kubernetes is secure by default, or somehow we're kind of bypassing some security measures by using Kubernetes. I hate to tell you, if you don't know already, that's not the case. And if you're a Kubernetes administrator, you already know that. But there's these same vulnerabilities that exist whether you're running on containers or not. So Kubernetes is not secure by default. And so we can apply the same measures in this ML-based web app security that we do in Kubernetes to those running on, bare metal or virtual machines anywhere in the cloud. This example happens to use Kubernetes because of these kind of easy to use plugins with, in this case, the Nginx ingress controller that allow you to tack on to the API or add on to the API to introduce this system to where you would better evaluate these incoming requests at the layer 7. And this one in particular that I'm kind of referring to is this open source project called OpenAppSec. OpenAppSec has in the past prevented their customers from, or administrators or people like me, from Log4Shell, and also the more recent more recent one that I discussed. So they're actually one of the only web application firewalls to do that. And so they have a lot of case studies that, they have a lot of proven methods to applying this to your Kubernetes clusters and beyond. So what's nice about this in the Kubernetes use case is that you can utilize the existing Kubernetes API, creating custom resource definitions, and allow this to be kind of more or less integrated into the Kubernetes system. So there's not much administration or installation that's required in order to apply this. So there's no reliance on signatures. There's a kind of two-stage approach to this. The first stage is an offline trained model to evaluate the possibility of a vulnerability, and this is all local to Kubernetes or local to your application. So based on that evaluation, that initial offline evaluation, the app then goes to an online model to further analyze those packets and those incoming requests. So so it's really nice because you don't have to rely on these signatures to find that really hard kind of should I let this request in or should I not sort of balance that we have to make as administrators. So it's really nice. And we can apply kind of this machine learning AI model to these incoming requests. And so we can, take a large pool of data, in this case, a trained model, and take millions of use cases and be able to apply them to this particular application or your application, and be able to machine learning is just finding patterns, right? So it's like, how can we find commonalities between these millions and millions of other potential vulnerabilities and make a good decision based on that data? And I like it because there's very, very low administrative effort because it's kind of automatic. So there's kind of like, I always call it your WAF on autopilot. So there's not a lot of tweaking and adding signatures, and the administrative overhead is very, very low. So it's nice. All right, so let's go through a little bit of a demo here, and I'll just explain it, and then we'll get to the demo. It's pre-recorded, so I'll let it play, and then we'll walk through it. But let me just kind of introduce what we're going to be doing in the demo. So the demo is going to be applying this ML-based web app security, OpenAppSec, to a cluster, and in particular utilizing the Nginx Ingress Gateway plugin. So we're going to attack an application that's a deployment within our Kubernetes cluster. We're going to attack the application by performing a SQL injection. Then we're going to deploy OpenAppSec for Kubernetes Ingress to protect the app. And we're going to attack after that's been applied. We're going to try that attack again, try that SQL injection again, and then ensure that the protection was effective. And then we'll look at some other options where we can kind of observe our cluster in a better way, and then monitor it over time and be able to more or less have a dashboard for those incoming requests and detecting whether detecting whether your app is vulnerable or not, really. So let's get to the demo. Let's see if this works. Hang on. All right. Everybody can see that? All right, so we have just a one node cluster. And by the way, if you wanted to run this experiment on your own, just go to openappsec.io, and it's part of their playground. And this is instruct kind of tutorial that they walk you through totally for free. So you can do this on your own to inspect the cluster even further if you wish. But for simplicity's sake, we just have a basic one node cluster. We have our Ingress Nginx deployed, so it's a pretty standard installation of our Ingress controller. And we have a web app deployed. This is the vulnerable app that I was talking about before. And then we have the service that is service type load balancer. So this is effectively providing the entry into the front end, the UI to our application. So that's what we have. We obviously have a service for our vulnerable app to, which is then the load balancer is directing traffic to it, and then to our pods. All right, so here's the UI of the app. So we're gonna try a try to do a SQL injection hack here, and try to log in. Boom. And looks like we have some numbers of revenue for this business, so that's not good. So we've identified a backdoor or a way into that app. So now we're going to deploy the OpenAppSec to provide some protection for our vulnerable app. So we'll just download the binary from the OpenAppSec site, and we can install this in many ways. One way is through the CLI, another way is through the dashboard or the portal if you like ClickOps. But we're just for simplicity's sake, we're going to do the CLI here and install it via YAML, just like anything else in our cluster. There's also a Helm chart for it, but the way that we're going to do it is just through generating those YAMLs and applying it to our cluster. So we have kind of a walkthrough here with the CLI. There's different kind of detection methods. So we're going to choose the prevent method, And what this allows you to do is kind of just turn up the protection, for the lack of a better word, to be more scrutinous or less scrutinous based on our comfort level. If we're a bank versus another institution that may not be exposing, I guess, as much vulnerable data. But there is certain settings within this application, so that's good to know. So we go ahead and apply this, and now we have created those custom resource definitions that I was referring to earlier, and we can take a look at those after the installation is complete. So we can get CRDs and just grep all the open AppSec ones. So we have custom responses, exceptions, log triggers, policies. Policies is probably most important. Practices, source identifiers, and trusted sources. So we can look at the policies. We can create multiple policies for multiple applications, or certain services in Kubernetes. We can customize those based on the level of comfort or access that we want to provide to our customers. So if we wanted to take a look at the YAML for that, we have certain parameters within that policy, such as the custom response, the exceptions, the mode. So that's kind of the tweaking that I was talking about. So prevent/learn versus restrict versus more stringent policies based on whatever your comfort level. And we can get the practice as well. So just looking at the YAML for the practice, which is one of those CRDs that we listed before. And so we can use a anti-bot to inject URIs and maybe add validated URIs if we know that we have some that we want to automatically pass through, so on and so forth. All right, so now that we've applied this OpenAppSec to our Nginx Ingress plugin, we can now go ahead and try to do that SQL injection again. And this time we get access denied, which is good. And so at this point, we can do one of two things. We can look at that dashboard that I was referring to. The dashboard is also included in the community edition, so all this stuff is free, which is nice. Hence the open source aspect of it. But we can also look at the logs. Just look at the logs of the pod and see what requests are coming through and whether they were prevented or allowed. And in this case, because we tried that SQL injection, the security action that we obtained was a prevent. So we see that we see that it's working. So that's a good. So going back to the slides here. All right, that works good. Let me explain in a little bit more detail how this works. I just basically installed it in our cluster and let it run. So a lot of hand wavy stuff, but let me go into the details for those who are curious. There's an analysis on the incoming HTTP request, and so there's the two stages to that analysis. The first stage, as I mentioned, was a trained model that's local to your system once you download the OpenAppSec binary. So this is a machine learning based enforcement engine and looks for attack indicators within that HTTP request. The evaluation of that HTTP request is based on a supervised offline ML model. I think I already mentioned that. But in this first stage, it's used with those millions of malicious and benign HTTP requests. I think that's important to point out, is that we're looking at all the bad ones in the past and all the good ones to find out the differences and properly train the model. And so these indicators can be as short as 1 or 2 characters. It can be, like we did the SQL injection, it was, I think, 5 or 6 characters. But it could be as short as 1 character in terms of those indicators, whether that's a bad or good request. And so the individual likelihood of that being a part of the attack is kind of initially evaluated in that phase, in that first stage. So then we have a decision, or the model has a decision to make whether to mark this as suspicious. So maybe some of those indicators have been found, or if it's benign, it's decided that it's benign, it's gives it a pass. In stage 2 is the once it's been marked as suspicious, we go to a stage 2, which is more rigorous analysis of that packet. So in the second stage, everything is about checking the context of the request. So in this phase, the model is an online machine learning model. So this is kind of acting internally, kind of egress out of your cluster and to the online model that is the OpenAppSec model. And so this second stage is the machine learning model is learning about specific user interactions, previous behavior. Did this request do suspicious stuff before? Where does this request come from? Does it have a reputation? All that good stuff. And it arrives on another kind of determination, and is given a series of scores actually to determine whether to allow or block that request. So this scoring system, this is kind of a preview of how these payloads are evaluated and what score they're given. So it's dependent on the user reputation score, the payload score, the URL score, the parameter score, and then it takes all of those and comes up with a total combined score to either allow that request to go through or to block it. So again, this is all open source. You can go and go to GitHub and search OpenAppSec and view this on your own. They have on openappsec.io, they have a wonderful case study that goes into some of the further detail about the evaluations and how these take place in terms of the scoring system and those 2 stages that I mentioned. And so I would encourage you to go to GitHub and check that out, and you can play around, and it's all open source, obviously, but also they have a good kind of community. They allow a lot of features in the community edition versus the paid edition, so it's quite nice. And this is the dashboard that I mentioned, which provides you with the visually aesthetically pleasing kind of indications whether incoming requests and whether those have been allowed or denied, and then just getting that data over time and determining if there's a period of time that you are under attack more than others, or just in general you need to maybe tighten up those policies to provide a better security stance for your app. So there's not just the kind of deployment method that we discussed. There's use cases for Linux, Docker, Kubernetes, the Nginx ingress gateway that we discussed, but also there's Nginx that's applied just to your general VMs running in the world or in the cloud, and then there's a plugin for Kong, as well as Nginx Proxy Manager, and some other integrations coming soon, such as Envoy, and also one for Istio. So yeah, that's all I got. Thank you. And I brought some books with me. If you want to track me down later today or tomorrow, you can find me somewhere, and I'll give you a copy of the Acing the Certified Kubernetes Administrator exam. So
You've also got about 5 minutes for Q&A if you want.
yeah, anybody have any questions?
What's the latency for the check that's being done on the request?
So it's very minimal, and I don't have exact numbers for you, but I would say that, you know, the way I discussed it is it seems like it would be a long process, but it's milliseconds. So it's quite nice in the response. So, but yeah, I encourage you to test it out and see for yourself. And also, there's a lot more information on that process and the time it takes on their website.
And the second phase, that's all local, right? No data shared, or is data shared back to like the other companies you're saying the same?
Yeah. So the second. I wouldn't say the data is shared, but the information, the metadata about the request is shared in that online model.
Okay.
So yeah.
So where is this model running? It's in Hugging Face or Kubernetes?
Yeah. So this model is kind of hosted by OpenAppSec and their parent company, which is Checkpoint. So this is kind of an open model. That's actually yeah. I did have a slide on that, but I was afraid that I would run out of time. But if you can, let's see, let me pull this up. It's based on the WAF comparison project. If you've ever heard of that, and so let me pull that up real quick to just show you. So this is what this is the GitHub page for the WAF comparison project, and so this is you know, in that online model, this is kind of what the metadata about those requests are attributed to. And so we can all kind of utilize both the benign and the bad requests that are coming through. So we can continually train this model to be better and better.
So how do you suggest this model to be used in financial organization? Because the request contains the PCI information, right? PII information. So in those scenarios, I'm not comfortable sending that metadata to a third party, right?
Right. In that case, you can leave the second stage out, and just use the local stage 1 version of the train model. It's still getting you a lot of the features and functionality of the WAF, but just takes out the more scrutinous analysis of that packet. So you're leaving out phase 2, but you're still protected from most of those attacks, being that you have everything local to your system.
You would have,
Go ahead.
Who is it?
so you would have a higher likelihood of false positives though if you leave out phase 2, right?
Right. That's exactly right. So you would have to do a lot more manual interventions or tweaking in terms of the policies and the allowance there.
Is there a way to include the second phase hosted within your own organization?
Not right now, not that I'm aware of, at least with OpenAppSec. But yeah, that may be an option in the future. So not aware of any opportunity to do that right now, though. Yes, sir.
In the first tier, is that inference require hardware? Meaning, does it require GPU?
Yeah, good question. I think the overhead is very, very minimal. I think because I'd have to look at the requests and limits of those pods, but it is very, very minimal CPU and memory. So
It's a pre-trained model, right?
Yes.
You're not training the model within your cluster.
no,
Okay.
yeah, it's pre-trained. Yep. Thank you. Back there.
Yeah, how would you characterize, or because with machine learning, your output or your decisions are only as good as your training model,
Yeah.
and models are very different. say that this model is good, and can we? Are there any indications on how to train our own model at all?
Yeah, so I don't know. I mean, you could. This is a open source project, so you could take that model and train it yourself, I suppose. But I think with the validity and the like you said, the ability for this model to be effective. I think you go back to the proof and use cases for this model used in the wild, and so there's a lot of data that proves that it has protected against Log4 shell, it has protected against many zero-day attacks, and so you're already utilizing a model that's been pre-trained and already is filled with the valid data that you need to protect your systems. So I think taking it offline or taking a copy of it and trying to train it yourself would be redundant, and I think not as valid and as useful. So that's all the time that we have for questions, but feel free to catch me in the hallway. I'd love to chat. So thank you.